Okay.
Hi, chemistry students.
Hi, guys.
This is Miss Gray and Mrs. Uy,
Yes.
and we're going to do podcast 5.2. So what I need you to do in your Unit 5 packet is find the page that says Bonding Basics. And we're going to flip in our packet and see which page it is.
All right.
Oh, page number 4.
All right, page number 4.
So you need this in front of you so that you know what to do and we can help you out.
Yes.
So today we're talking about how do ionic bonds form.
And look at the section A in your packet.
Right? So we're going to start by talking about atoms. So how many protons are in sodium?
How many? Well, number of protons should be the number of the atomic number, right?
Right.
So sodium, if you're going to look at your periodic table, it's 11. So number of protons is 11.
Okay, so in a normal sodium atom, how many electrons?
There should be 11.
Right, in a
Yeah.
neutral atom,
Write
there's
that down, 11.
Okay, how many of those 11 electrons are considered to be valence electrons?
There should be 1.
Right. We went over this in Unit 4. When we did the dot structures, we would show sodium like this with
Yes,
only one dot.
dot.
Because it's the first one on the periodic table.
Yes.
When you count from left to right. So what would you predict for the charge? Do you think that this electron is going to stay there?
No.
Okay. What do you think would be more likely? To lose one electron or to gain 7 more?
I think it's easy to lose 1.
Right. Probably so. And so if we lost a negative particle, our charge would become positive.
All right.
So that's what we predict for the charge of sodium.
Or they can just write +1 this way, or 1
Yeah.
plus.
Yeah, let's put 1 plus.
Okay.
Good idea. You don't need the 1 because
Yeah.
it's implied, but it's good to write it so we know.
Yeah.
All right, let's look at chlorine on the periodic table.
All right. Chlorine in the periodic table is number 17.
Okay.
So number of protons is 17.
And so we must have 17
17
electrons.
electrons.
How many of those are valence electrons for chlorine?
Those 7.
Right. If we count across from left to right, we would add up to 7 total electrons. So I
Yes.
draw my dots and then I write, okay, there's 7.
7.
Got it. So to make 8 electrons total, we only need 1 more. Or we could get rid of 7.
I think it's hard.
Yeah, that's too hard.
Yeah.
So we'll add 1 more electron, which makes our overall charge negative.
Negative. Yeah.
Okay, next.
Next is the element beryllium. In the periodic table, it should be number 4.
All right.
So number of electrons, number 4.
How many of those are valence electrons?
Valence electron should be 2.
Okay, so
So
I would
2
draw it
dots.
like this, and I'd have 2.
2.
So what do you think will happen? Gain 6 or lose 2?
I think it's easy to lose 2.
Good.
So that should be 2 plus.
Right, so losing electrons gives us a positive charge.
Positive charge.
Right, because electrons are negative. If you get rid of your negativity, you become more positive.
Positive, yes.
Okay, fluorine.
Fluorine is number 9. There you are.
All right.
Number of electrons, 9.
Hey, fluorine's in the same family as chlorine. So, for valence electrons, they would be the same.
They would be
That's
the same.
why they're in the halogen family, because they have
Yes.
7 valence electrons. What do you think we ought to do now?
That should be F1 minus,
Right.
right?
Gain 1 more,
Gain one
and
more.
we'll be like a noble gas.
Yes. Like lithium is number 3.
Okay,
Number of electrons, number 3.
all right.
Okay. Valence electron is, of course, 1.
Only 1, it's an
Only
alkali
one.
metal.
Yep.
All right. And so its charge is going to be
+1.
+1, because that 1 electron will leave, and we have too many positives left
Yes.
behind.
Okay,
Okay,
oxygen is very easy. It's number 8 in your periodic table.
Okay,
So number of electron is 8. Valence electron is 6.
right.
So 6 dots.
I'm going to sketch those all in, 6 dots.
6 dots.
All right.
And that should give us 2 minus as a charge.
Okay, tell me why.
Well, because oxygen is going to gain 2. 2 more to make it 8.
Right, I need a
Right.
partner right here in this spot
Yeah.
and one right here in this spot.
It's easy to gain 2 than to lose 6
Absolutely.
for oxygen.
Great, let's do
All right, the
phosphorus
last
then.
one is 15. Number of protons.
All right,
Number of electrons is also 15.
okay.
Valence electron is 5.
So let's see, how do I do 5? 1, 2, 3, 4, and then 1 more.
Yeah.
Okay, so 5.
5. So to make it stable, to make it 8, we need 3 more.
We need 3 more.
Yeah,
So
it's
if we,
easy to gain 3.
yeah, losing 5 would be hard.
Yeah.
So if we add 3 more negative particles,
That
we'd have a
should give
charge
us
of -3.
-3.
Great. So that part of the table is easy to fill out. But now let's talk about how these could go together. If sodium needs to lose 1 electron and chlorine needs to gain 1 electron, we could put them together.
Yeah.
Well, that's what we're going to do next.
Okay.
Okay, so here's our basics for making ionic bonds. Atoms that gain 1 or more electrons will have a negative charge.
Negative charge.
We saw that, like chlorine had to
Yes.
gain 1, that made a -1 charge. And an atom that loses electrons will have a positive charge.
Yes.
We have special names for these that we learned in Unit 4. If it gains or loses electrons,
Yeah.
we call it an ion. Do you remember the name of the positive ion?
Positive ion is the cation.
Right.
Cation.
Because, wow, I'm drawing on it. Whoops. Because of the T in the middle, positive, right? Cation.
Okay.
Those are positive. And negative anions are called anion.
An ion.
Yeah.
Okay.
So an ionic bond is formed when atoms transfer 1 or more electrons to
To
another.
form.
And then they form a bond
Form a
because
bond.
we have 2 oppositely charged particles. They
Yes.
stick together.
Mm-hmm.
Each of the atoms then is left with a complete outer shell. And by complete, how many do we mean?
8.
Yeah, 8 electrons. Unless
8
it's
electrons.
helium or hydrogen, they can only hold 2
Yes.
because they're in that 1s.
1s.
Okay, an ionic bond forms between an ion with a positive charge. Remember what we called those? Cation.
All cation. We just talked about that.
Oh, wait. Oh, wait. I'm doing it
No.
wrong. An ionic bond
It's-
forms between a metallic metal
It's called, yeah,
and a non-metal
non-metals
that has a
negative
negative.
charge.
Right. So if you look at the pattern from our chart that
Yeah.
we did before, the metals we're losing,
Mm-hmm.
non-metals we're
Non-metals
gaining.
are going to gain.
All right, so now we're going to draw some dot structures. I told you, oh look, I have all these words. I forgot.
It's okay.
Yeah. Good thing we wrote the right words.
Uh-huh.
Okay, so let's see sodium and chlorine.
All right. So
We
we're talking about
said-
ionic bonding, right?
Right.
Okay.
We said sodium has 1 electron
Mm-hmm.
in its valence shell, and chlorine has 7.
Yes.
And sodium wants to give away that electron, so let's put it there where the chlorine needs it.
All right.
All right, so I move it
That
over.
makes chlorine complete.
Yes, and sodium's good now too, because it drops back to the level 2,
Level 2, which is also,
complete.
yeah,
Right.
complete.
So now what sodium has is 1s2, 2s2, and 2p6.
Yes.
And so that's good,
Mhm.
because that's like a noble gas.
Yes.
That's very stable. All right, well, if sodium loses an electron, then it has a positive charge now.
Yes.
So I put in the plus sign for its positive charge.
Uh-huh.
Since
And
chlorine
Cl,
has too many,
too many, it's negative
it's a negative charge. Why do they stick together?
because opposite charge attract.
Yeah, opposites attract. Yeah. Okay, so let's write the formula for this. Did I write it down? Nope. Let's write the formula for this for our students.
All right.
NaCl,
Cl.
one of each. So we just write NaCl.
Yeah, NaCl.
And then we name it. We always name the positive
The
charge
positive
first.
charge first, so that's sodium.
And then at the end of our negative charge, I'm going to change the ending to IDE.
So that makes chlorine chloride. So our name for NaCl is sodium chloride.
Exactly.
Very
It's that
easy.
Okay,
That's
let's
easy.
try another one.
All right.
Magnesium has how many valence electrons?
Okay.
It's an alkaline earth metal in
Uh-huh.
group 2.
All right.
So if we count over from left to right, we only go 2 spaces.
2 spaces.
So I drew 2 dots
Two
for
dots,
magnesium.
yeah.
Bromine is a halogen like chlorine.
Yeah.
So it has 7.
7.
All right, now this time I'm going to move this electron from magnesium to bromine.
Mm-hmm.
Okay, but now I still have 1 left.
Yes. So we need one more.
We need a
Bromine.
place for it to go.
Yes.
Let's get another bromine, like you said, and
Yeah.
move this electron to the second bromine.
Yes, exactly.
Okay, and then
So
our
now
charge
our Mg is
Mg is a 2
2 plus because it loses 2 electrons.
Right, and each bromine only gained 1.
Yes.
So that's a 1 minus. Let's write the formula.
All right. Name the
So Mg
right to
goes
positive
first.
first.
And then there's 1 Mg, 1 magnesium,
Yeah. And we
but
have
2 bromines. Oh wait, do I need to put a 2 in front? Two bromines?
No.
Where does it go?
It should be a subscript 2.
Yes, sub means it's down lower.
Yes.
Right, so a subscript MGBR2, we write the 2 down low.
Yes.
Now we'll name this. We name the positive charge first and change the ending of our negative to IDE.
To IDE.
So we name this one magnesium,
Magnesium bromide.
bromide.
And the symbol is MgBr2.
Good. So now we know how to make ionic compounds. We can see how to write the formulas and how to write the names.
Yes.
We're going to get lots of practice at this, but I think we should do a couple more.
Yes.
Okay, let's do potassium, which is also an alkali metal,
Yeah.
and iodine. Oh dear, I didn't have these dots. We have to write them ourselves.
Oh.
Oh, can you
Okay.
believe we're going to have to work now? Okay, 1 dot for potassium.
Okay.
How many for iodine? It's a halogen.
It's a halogen, so it's 7.
Okay. We can see now where this electron needs to go. This electron needs a partner for iodine. So we're going to take the one from potassium and move it across.
All right.
So I'm going to show that. Now potassium doesn't have any, and iodine gets to have 8.
8.
Now does that mean potassium has no electrons at all?
No.
No, because it still has the
Yeah.
core electrons.
Yes, the core electrons.
It just gave the
one
valence.
just means to say the valence electrons.
Right, exactly. So now this one has a positive
Positive
charge,
charge.
and this has a negative charge.
one.
So they stick together to form this compound. How would we name this one?
It should be potassium
Mm-hmm.
iodide.
Yeah,
Don't forget to change INE to IDE.
right, iodide. Good.
All right.
Example 4, lithium,
Lithium, Li is,
alkali metal,
all right, 1.
And
And
then
then oxygen is 7.
6.
Oh, 6. Sorry, 6.
Yeah, I think 6.
Yeah,
Let's count
6.
across on the periodic table.
Yeah, 6.
All right. So now when I move this electron over, then I get a partner here for this electron. Whoops.
Yes.
Hey, put it in. But I still need one here.
Yes, there's only 7.
Hmm.
Okay.
So let's get another lithium.
We need one more
Yeah,
lithium.
because chances are in our beaker of lithium and oxygen,
Mhm.
there's not just one atom of lithium. We
Yes.
probably have another one. So we're moving these over. So now I have lithium here with a
Lithium.
plus,
Mm-hmm.
and my oxygen
Oxygen.
has 8. And then I have another lithium down here that's a plus, since oxygen gained 2 electrons.
So that's 2
it's
minus.
a 2 minus.
Now, how are we going to write the formula for that?
2
So
lithiums.
we have 2 lithium, so we have
A
Li2,
subscript.
a subscript 2, and then oxygen.
Right, we always put the positive one
Yes.
first, and then we name the positive one first. So we have lithium, oops, I was writing bromide. Lithium
Oxide.
oxide. Great,
All
that's
right.
not too bad.
Yeah,
We have 2 more left, and then we're almost
we're
done.
almost done.
Calcium has 2
2.
valence electrons,
Mhm.
and then fluorine.
Fluorine has 7. Right?
Yep.
Okay.
So I'm going to put another one over here, because I have an electron here that needs a
Yeah,
partner.
we have 2 Ca. I mean, 2
Yeah.
electrons from Ca.
Okay, so I
Ca
can
needs
see-
to give up 2.
We'll put one of them here and one of them there. How's that look to you?
Looks fine for me.
I think that should work.
Yeah.
So calcium is a 2 plus,
And F
and each fluorine is a minus
is a
1.
-1, and we have 2. Yeah.
Does it matter to you if they put the 1 before the minus or after the
I
minus?
don't think so.
Okay, it doesn't matter to
Doesn't
me either.
matter to me.
How do I write this formula to
All
show
right.
how many of each thing?
So we have Ca.
Right? Positive thing first.
Positive.
How many fluorines?
We have 2 fluorines, so we're going to put 2 as a subscript.
Okay, let's name it. What do we do at the end?
Calcium fluoride. Change INE to IDE.
Yep, calcium fluoride. Great. Last one,
All right.
aluminum.
Aluminum.
Oh, this one could be a challenge.
Yeah, that's 3, right?
Yeah.
We're going to count.
And oxygen has 6.
6.
How are we going to make this work? Let's see. I'm going to put X's for oxygen so we can keep track of which electrons are which.
Mm-hmm.
All right, so there's one oxygen that can take this one.
Yes.
And then I need another electron over here. Okay, so I still have
That
one.
completes. I
Let's,
still have 1.
all right, let's put another oxygen and see what happens. Now I can move this one, but oxygen needs another electron.
Yeah.
Let's have another aluminum then. Okay, so we put another aluminum, and now I can get this electron a partner.
Mm-hmm.
But now I
You have 2.
have more electrons left. So let's have another oxygen come along.
All right.
Oxygen has 6. And hey, this works now. It all evens out.
Yes.
Okay, so you notice aluminum was a 3 plus.
3 plus.
Because each aluminum gave away 3 electrons.
And we have 2 aluminums that gives away 3.
Right, and then the oxygen was
will
a
be
2 minus.
2 minus.
So we had to find something that worked for both.
Okay.
That's why it took so many of each thing. How many aluminums did we use?
We have 3 aluminum. Right? Oh, 2.
2 aluminum.
And 3 oxygen.
Right. So we write the formula to show 2 aluminums and 3 oxygens. And how do we write the name? Aluminum goes first,
All right.
and then
Oxide
oxide.
for oxygen.
Right, so we are just changing the ending to IDE.
Oh, yeah. That's very easy.
Yeah, and we're going to give them a naming card so that they can look to see
That will help
what
them.
it does.
Yep.
Yeah, great. That's it. So use your periodic table to help you draw valency electrons and
Yes.
predict the formation of ions.
And do they have any worksheet that they're going to work on?
Yeah, they're going to do a group thing in class.
Okay.
The,
Well, that's
Poggle.
good because they're going to work in group.
Yes, we
Yeah.
want you to work with a team to figure out how to name these things.
All right.
All right, that's it, guys. Have a
right.
good one.
You want to work on that one? You want to work on that one today?
Which one?
Yeah, I should.
I don't know yet.